believe I would, if I have a negative there, then I should have a positive there with a minus and negative from the ultraviolet blue, yes? Okay. We'll check our answers at the very end and see if we agree. Distributed out, that's e to the x sine of 2x minus 2e to the x cosine of 2x minus the integral of 4e to the x sine of 2x's, which you then can move over with the other integral of the same nature, yes? So you should have 5 e to the x sine of 2x's dx's equals e to the x sine of 2x minus 2e to the x cosine of 2x. I guess you could put a plus c there, or in the next step, as long as I have one by the end. Do you have that answer is e to the x sine of 2x minus 2e to the x cosine of 2x all over 5 plus a c? No?
Well, maybe because you have the extra negative from the negative 4 sine of 2x, and then you have a negative from the ultraviolet blue. Wouldn't that be a positive 4?
This guy? So I have, let me do this without any simplifying. I have minus from the ultraviolet voodoo, and my du is also negative. So altogether, I feel like I have 3 negatives.
Oh, okay then.
Do you agree?
Yeah.
Okay. So, yeah, I think if you had 3, then if you had a 3 here at the end, you probably maybe lost a negative. Okay? All right. Let's go on to vector value functions. This is a good one. Is this recording? Yes. Okay. This has a gob of overlap with parametric, but it's useful for Calc 3 especially. If you do a nice job at this, Calc 3 and higher level physics will go a little smooth. All right, so as much as possible. So that's the first thing. By way of introduction, you're going to see a ton of overlap between this and parametric. It goes like this. We've dealt with vectors before that were only constant. For example, vector v is 3, 5, which is horizontally 3 and vertically 5 and doesn't change. Or vector u is 2i hat plus 4j hat. Those are both forms of component form, horizontal, vertical. Or we could do polar form, 5 at an angle of pi over 2. All those are vectors you've been doing. It is, however, possible that horizontal and vertical components could change over time, in which case the vector is a function of horizontal and vertical components that vary. It might look something like this. You still have the pointing component form, but instead of constants in the vector, they're varying functions, one horizontally and one vertically. Same deal though, you could use 2 different notations. You could use the pointing parentheses, or you could use I hat, j hat, and possibly k hat when you go 3 dimensions. You'll see both. What you don't typically see though is vector valued functions in polar, at least not for a while. All right, so let me go a little further. Because they use horizontal and vertical, they are very similar to parametric. So let's do a little compare and contrast here. This is a parametric case. This gives you position horizontally and vertically at different times. I could, for example, graph this baby from 0 to 4. At 0, where is it? Negative 1, 4. Negative 1, 1, 2, 3, 4. It's right there. At time 1, where is it? 0, 3. At 2, where is it? 1, 2. And at 3, where is it? 2, 1. And at 4, where is it? All right, so here's the path. Here's time 0, and it's moving that way, like we've always done. We could have eliminated the parameter, and I imagine we would have got the equation y equals negative x plus 3, but you understand. You follow? All right, then. For parametric, each outcome of when I put a time in is a point. It's a location. Let's compare that to a vector valued function. You can see then that the same functions. However, when I put in a time of 0, I don't get out a point, I get out a vector, which is to say I get out the vector -1, 4, right? You with me? Now, assuming we draw from initial position or put the starting point at the origin, then my first vector is this. My vector I get when I put in time 1 is 0, 3. So vector 2 is that. When I put in time 2, I get a vector of 1, 2. That. When I put in vector, or put time 3, I get a vector of 2, 1. And at time 4, 0, I lost my place. What am I doing? 3? Okay. So the graph of a vector value function is actually a ton of vectors. Now surely the outcomes, the ends of the vectors represent that same path, but a vector value function creates a whole bunch of vectors. I'm drawing from the origin, but this whole graph could have been like that, yeah? I don't necessarily remember when you draw vectors, you don't have to draw from the origin. The whole graph could have been there. Okay, now that's a vector value function, and it's got some ins and outs that we'll gradually look at. Yes? Somebody say this correctly? Who did? Yes. What? Oh, yeah, I'm sorry. Should be 3, 0. You're right, sorry. My bad. Thank you. That's the old critical thinking kid. All right. The rest of them will probably are also thinking he's wrong, but that's okay. He's wrong all the time. Are you with me? All right. Now, we typically then take the derivative of vector value functions for a lot of reasons. In calculus, you just focus on the how of it, not so much the applications, but I'll leave that to your physics education, hopefully. I will say this is pretty much all physics. You don't do this in business. You don't do a vector value function in a business application. All right. So the rate of change of a vector valued function is also a vector valued function. When you take the derivative of this vector function, you get a vector function. And the notation of that is something like this. Now, I was calling it u or v before, but it's pretty common that if you have a vector function, you call it vector f, which is a function of time in both horizontal and vertical components. The derivative then is vector f prime, and you just take the derivative of each component. Now the domain is the iffy point here. You have to, at least in our book, they definitely are picky about the domain. You need to include the domain, and the domain is the intersection of both. I'll explain in a minute. All right, so say you had this function, and I asked you for the derivative of that vector value function. What is the horizontal derivative, x prime? Cosine of 3t squared times 6t. And the horizontal, or the vertical component rather? 4 plus t. Okay, now they did say include the domain of the derivative. So we need to include a domain restriction. What is the domain? The time is equal to or greater than -4. Whether he would have even positive values, it kind of depends on the problem, but we'll include it. Time must be greater than or equal to -4. I actually have a little bit of a problem with that. What is the problem with that? You're a little wrong. That's not my issue. So assume time negative is fine. I still think your domain stinks. Yeah, it should not be inclusive. Why not t equal? That's undefined. So it should not be time is greater than or equal to. It should be strictly greater than -4. There are two restrictions at hand there, the root and the denominator. So it should be strictly time greater. All right? Okay. Let's go then to using this to talk about position, velocity, and acceleration vectors. Just like you have a parametric position and how it changes, we also have those ones in vector form. So say I gave you a velocity vector like this, and I gave you an initial position at a certain time, and I wanted both the position vector p and the acceleration vector. Let's do vector p. Let's start with the horizontal component, x. How would you find the horizontal component anti-differentiate? So, and we have an initial condition. What are the two ways to integrate and use the initial condition? Add C and use the initial to find C, or a definite integral fundamental theorem, start plus change, right? Which you want to use, the plus C version I heard? All right, so if you do the plus C version, and that's T cubed plus T plus C, and if we use that, the position is 1, 3 at 1, then what do I put in for it? X is 1 when time is 1. So 1 equals 1 plus 1 plus C, which implies C is -1. And I have the first part of my position vector. The horizontal component for the vector value function is T cubed plus T minus 1 for the horizontal function. Yeah. Oh, you mean you could integrate mentally and find the C mentally? Yeah, I want it all. I don't know, I guess I could. I would be okay if you. No, that's good. Yeah, let's go yes. Actually, give me a pause for a second. Since we just talked about AB, something you really need to guard against is being too smart. You will sometimes lose points on the AB test because what you think is everybody knows that. No, your AB, does that mean it's not that? Your AB free responses are in a stack with some other AB kid. Now, I'm not talking AB kids at this school. I'm talking some kid in Ray who's learning calculus from a gym teacher. You know what I'm saying? You need to separate yourself from them and say, hey, I know what I'm doing. This is what I'm doing. All right? You need to show the work. Don't get too smart for your own good. All right? Thank you for reminding me. I want to do that little correction. So y is the antiderivative of cosine of pi t. Now I kind of regret saying that because now you think, so do I have to show you stuff on that? And we'll talk about that later. No, let's not show you stuff on this, okay? What is the antiderivative? 1 over pi sine of pi t plus c. I should really call that some other c. And what is the initial condition there? 3 equals 1 over pi sine of pi times 1 plus c2. So c2 is 3, and therefore the vertical part of the vector function is 1 over pi sine of pi t plus 3. Check? Okay. Acceleration then. Acceleration is a lot easier. It doesn't require nearly as much work. What is the horizontal component to the acceleration vector? 6t, and the vertical component? Negative pi sine pi t. Okay, very cool. Any questions? All right. Now, this is a pretty common BC question, and if you're good at this, this is usually a 9. This is where you really make some hay and get yourself some leeway. So, speed and distance in vector value functions. when you think about basic linear movement, speed is what? How does it relate? How do you find speed? Absolute value of velocity, right? It's change of position without respect to sign or direction. Distance is the integral of speed. Okay? When you want distance, you say, I don't care what direction you're going, I just want to know how far you are. And so you use speed rather than velocity, yeah? In two-dimensional movement, it's the same thing, except in two-dimensional movement, I have horizontal and vertical change, and I really want how did it change, period, and so that means hypotenuse kind of calculation. Speed is how it's changing, the rate at which it's changing horizontally, and the rate at which it's changing vertically in a Pythagorean theorem kind of calculation. Now that said, speed is still a scalar, not a vector. There's no direction to it. It's all positive action or zero at the minimum. Okay? Distance then. Distance in two-dimensional movement is just like before. If speed is the absolute value and distance is accumulation of speed times time calculations, same in rectilinear or planar movement. Sometimes you'll hear this called planar movement. But it's still the integral of speed, which makes it look a heck of a lot like arc length, and truly it is. It's arc length in vector function. It's like I said, there's a lot of overlap between parametric and vector valued functions, a lot. All right? So, for vectors, if you're given a velocity vector, which is change in x and change in y, respectively, then speed is, what was I getting at? Is this different? This is the same. Is there any difference here? There's not, so it's the same. Okay? It's just like parametric. Yeah, velocity versus speed. So my point, sorry, I'm trying to make, which I made badly, is parametric and vector valued functions behave exactly the same for speed and distance. You with me? So let's look, let me show you what a problem might look like. If I give you a position vector, now this gives the position in a vector form at lots of different times, horizontally and vertical, and I wanted the speed at time equal 2, then the speed, or the magnitude of the velocity, is the calculation of, at time equal 2, we take the derivative of position, which is 6t, quantity squared, plus negative pi sine pi t, all that squared, and we evaluate that at 2, whatever that is. You track it? Okay. If I asked you for that same vector, find the distance the particle travels from time 0 to time 2, then what do I do? Integrate from 0 to 2 the horizontal rate of change or vector derivative and the vertical. Integrate speed, in essence, with respect to time. And boom, you're rolling. Easy enough? Okay, that is it. All right, questions on set 122, 4. Did I hear 18?
Yes.
18,
8.
8,
23.
23. Did I hear 6? 23 I heard.
4. Oh, yeah.
Okay. All right. So, I know you did this last year, but recalling it is another thing. It says each time a rebound is 3/5 of the previous fall. So the first rebound is 3/5 of 8, and the next rebound is 3/5 of 3/5 of 8, or 3/5 squared of 8, and so on. 3/5 cubed of 8. Okay. The hard part, or the gotcha to this, is that if I were to list the distances, the first distance is 8, the second distance is 3/5 of 8, the third distance is 3/5 of 8, because it's up and down. And then it's 3/5 of 3/5, so 3/5 squared of 8, and again, up and down. So the gotcha to this is that this is not geometric if you put all the trips together. So the thing you must do is split them up into up and down in some fashion and deal with them separately. Now that could be done a whole ton of different ways. You could just find each one, or you could find all the downs and double it and add 8, or find all the, there's a lot of ways to do it. But I'm just going to go this way. The distance down. If I look at all the downward distances, the first down is 8, then 3/5 of 8, and it's geometric and so on. It is geometric. The common ratio is 3/5, which is less than 1, so it converges, and therefore the sum for distance down is A1, 8 over 1 minus 3/5. The total distance down is 8 over 2/5, or was it 20? Okay? Distance up, the first upward distance is not 8. The first upward distance is 3/5 of 8. Then it starts that same geometric R. So it is also geometric. The R is still 3/5, which is less than 1. So the distance up can be used, the formula can be used. The only difference is A1 is 24/5 for the first term, not 8. And so 24/5 over 2/5 is 12. See? That makes sense that it's 8 less because it doesn't have that first 8 drop. Yay! So distance total is 32 meters. Okay, your work could look different than that. There's a lot of different ways to do that. Okay. 18. Is 18 still a question?
18 was just not.
Is it replaced or straight up normal?
Straight up normal.
Okay. What a mess. All right. So, first of all, write small. First derivative is fine. It is t cosine of t plus sine of t over t e to the t plus e to the t. Do you agree with my first derivative? Okay. Second derivative is where it gets gross. There is a ugliness factor and a conceptual place you need to be careful for. The second derivative is the second derivative taken with respect to x, not t. And so when I take the derivative with respect to x of the first derivative, you will have to take the derivative of the inside, which is this big, huge mess. But then, via chain rule, it's the derivative of that times the derivative of t with respect to x. Now, we typically don't usually write that over there. We usually write dx dt in the denominator. I'll deal with that in a second. Are you with me now? Because you're taking a derivative of a t expression with respect to x, you pick up a dt dx. So, here we go. Quotient rule says low t e to the t plus e to the t. D high. D high starts with product rule. First stays the same, derivative of the second plus second stays the same. Derivative of the first plus cosine of t for the derivative of the sine of t. That's low d high. Are we cool? Minus high t cosine of t plus sine of t d low. D low is product rule. First stays the same, derivative of the second, plus second stays the same, derivative of the first, plus e to the t. Low d high minus high d low. Over low low, or over the square of what's below. Now, that's the derivative of the inside, but then times dt dx. So if you were to, let's not write that again, shall we? Okay, instead of dt times dt dx, are you okay with me saying divided by dx dt? Okay, and dx dt is what? T to the t. So you can imagine that maybe a slightly different form of the answer is a multiple choice. What's the most common multiple choice? Instead of written it this way, you'd probably see it with the denominator cubed. Yeah. Right. Yes, sir. Just as long as you can pick your answer up. Right? 18 is a check. 8. Question on 8. Is 8 still a question?
Yes.
All right. Is it changed anyway or straight up book?
Straight up book.
Straight up book. Okay, so 4 plus 2x.
Oh, wait.
Oh, does anybody need this?
Oh, Jordan does. She was talking.
Jordan, yes?
Wait, what? Yeah. Oh.
Oh, I just asked her, is this the book? And she said, yes, that's all. Nobody needs 8? I appreciate it. So we're good. Yay, good. Time saved. 23. Question on 23?
Yes.
23 is yes.
Wait, here.
All right. Okie dokie. Okay. You can also use differentials here if you prefer. It's 90% the same work. It really is. The point is 2, 1, the slope. We need to do some implicit derivative work. Wait. Check your first derivative. First stays the same. Derivative of the second is that. Second stays the same. Derivative of the first. Minus. Second stays the same. Derivative of the first stays the same. Derivative of the second. Minus. Second stays the same. Derivative of the first. Plus 3 equals 0. I am seeing 2 dy dx terms. How about you? Alrighty then. So I'm going to keep these two guys on the same side and call it dy dx times a factor of 3xy squared minus x squared. On the right hand side, I would move everything else over. So 2xy would be positive, negative y cubed, and negative 3. If you see an error, dy dx therefore is 2xy minus y cubed minus 3. I guess I could have put in numbers first. Would that have been easier? Would it have been better to put numbers in earlier? Okay. Just maybe less writing. 2, 1, 2, 1. All right, so evaluating that at 2, 1. Is, what do we got there? 4 minus 1 minus 3 over 6 minus 4. I'm feeling 0. Well, there you go. There's a horizontal tangent there, yeah? Did you get a derivative of 0? Cool. So that means I would expect it going a little to the side that the y would stay the same. So I'm doing 1 is my estimate. But if you wanted to write a tangent line, it would be y minus 1 equals 0, x minus 2, so y equals 1, so y equals 1. That is, so it's basically saying this. At 1 it's, at 2 it's 0, and 1.95, I'm saying based on the way it's changing at that point, I would expect the y to be the same, so the estimate is still y. That is my estimate. Okay? Other questions on 122? Cool. Yay! All right. I'm a little behind in my homework grading, but I'm going to get caught up tonight sometime, so you better keep yourself caught up. What? Yeah, these
So if there's a awning, is there
So
yeah, what would be important because it's awning.
this homework is not doing it for us. Okay? Just, I just want to measure how you hear this. It should be it's a test. It's a test. It should be
Studying life stuff, right?
don't study, but you gotta watch it. You bet. No problem. Yes. Yes, because you're looking for. How fast this is, because you're looking how this is changing. Right. Have a lovely day.
This works fine. Alex?
I am not. I'm sorry. All right. Alex, you got to stand on time going in there, buddy?
What's that supposed to mean?
You don't always have your sets on. Sorry. Is that too weak for you?
No, I've been doing good this semester.
Attaboy, all right. Keep it up. You're welcome. Have a great day.
I'm trying to sign up for 7th hour, but it's not like.
Oh, yeah. Somebody told me there was a calculator or a computer. Excuse me. I signed up first. I will have to ask her, I don't know what she's doing. Right, go way back to this class and sign up somewhere else, try somewhere else.
We learned in Mr. Damon's class that he's an Uber driver. Mr. Damon's Wait, really? Yeah.
You know what? That's like your source of income.
It's a wonderful. He said like on Halloween you make like $60.
Daily?
Yeah.
Oh, yeah. Yeah, he told me that. He's like, on Halloween, it's like 10 times what I usually make.
For you?
I feel, except I'm probably not being second for that. It's a driving experience. Like driving experience.
You want to know what I do?
Yeah, that's also a problem.
Switch those two different stores to those subtract double.
This isn't like it seems like it's it's like million.
I stopped those on California yesterday and it's on my
I feel like good. I like being screwed on.
I finished my audio book and I'm on the third book of the series. It was only 2 minutes. No, it's a 12-hour.
All right.
I started it 2 days ago. I listened to it 3 hours last night, an hour today.
It says AD.
Yeah, let me explain that, buddy boy. Okay, so I'll fix that in a second. So here's the deal. Let me explain about the plan. You can see, you might be able to see, tomorrow, A/B practice test 1A. I want to guard against you getting too rusty on your A/B material. So I am going to give you at least one A/B test over the course of the semester broken into thirds. So tomorrow, you will have a in-class test.
Is it for a grade?
It is for a grade, it's for a test. Before you say, okay, first of all,
Yeah, that's what I was
you're
gonna say.
gonna thank me later. I looked at this, so I gave you, you're actually doing the first part of that test right now. Five multiple choice A/B questions. Now look, I basically thumbed through it here. I have 29 students here. And I thumbed through this and I was able to grade this in about, just like that, about 7 seconds because I only saw 2 missed questions among 27 times 5 or 135 different responses. So it's a gift. You're welcome. It's easy. It's much easier than it'll be easy, right? I just need to make sure that everything's going well and you're not forgetting anything before it's too late. So, the good news is tomorrow's an easy test that'll raise your grade. The good news tomorrow is that it's all in class, so you will not have homework. The good news is that because you won't have our homework tomorrow, today's homework's not due until. Good news all over the place. No, there's no bad news. It's all good. Okay?
Someone just died.
Somebody in the world did just die, so that's bad news. But it's unrelated to the test. Yeah, but a baby is born. Take that.
Yeah, take that.
And then you're positive, put a zero.
The person died every 3 seconds and the baby's born every 5. So,
Isn't
No,
that,
people are more fast
isn't
than they
population
are.
grown?
world population is
Yeah, it's like, unless there's babies being manufactured. All right, yeah. So that's it. You're going to do this without friends, without a calculator, just you and your noggin. More good news, I'm only grading the answer, not the work. So do as much or as little as it takes. Keep your little grubby eyes to themselves, though. I know the desks are a little close, but do not look at other people's papers, you cheater things. When you are done, I will get you a tunnel set while you're working on this, and you can work on that worm up on the board and say, all that kind of stuff. All right? Max of 10 minutes. That's per AP. Generally, you have 2 minutes per multiple choice on the little calculator. There's the back part. I'll make sure you do the 2 on the back. Just raise your hand up and we'll get it. That was work on 7 and 6 for a one. You guys still working? Okay. Easy enough, eh? Oh, Ranger. I'm gonna call you out for this one.
Is that anything to do with like?
And Nathan was proactive, he already called it something.
Well, I think I did the first one because I did it reading the two lesson and I did it again. And then I went back again and I almost turned it in without.
I saw 3 missed questions. That's pretty good.
Does that mean? Yeah.
I don't know, I didn't look at any names.
What questions were they?
All in the back.
2 out of 5.
The back was we've got 4 questions, but ED.
Was that the 11
Yeah, that
thirds?
was too long ago. Was
11 thirds is the slope, I believe, yeah.
What was
And
the
then
second?
between -10 and 7?
Yes. All right. So tomorrow will be nice and easy. Tomorrow will be 10 multiple choice and 2 free response. Okay, you have these done? Okay. All right, while you do these two, get a cup of coffee, done in our back. I'm going to put it in. Seemed like you were causing trouble then while I was gone.
You're right,
Yes, are you ready? All right, so how did tabular go? Did you get something like x squared e to the x minus 2x e to the x plus 2 e to the x plus c? Is that right? Yeah, it's because of the it's in the ultraviolet voodoo. It's because of the negative in the ultraviolet. That's why. Okay, I don't want to make it sound just cut. There's a reason. Okay. All right. If you do not agree or did not get that or you don't understand yesterday's, let me know. But I don't want to waste time with those to get it if it's going well. This one is a little rougher. And now I'm going to use this one's pretty lengthy here. If we use ultraviolet voodoo twice, then what did you let u equal? Sine of 2x. I generally, students have a better time of doing derivatives of Oakley than inside derivatives. So if you do that, then du is cosine of 2x times 2. Or 2 cosine of 2x v, and e to the x for v. So my first run through is e to the x sine of 2x minus the integral of 2 e to the x cosine of 2x dx. Yay? We do another integration by parts. Be consistent. If you did u as trig before, you do u as trig again, except now u is cosine. Did you put the 2 in with the e or the cosine? Cosine, okay. Or factor it out front. Either way, just be careful. If you put in with the cosine, then du is negative 4 cosine of 2x, yeah? And dv is e to the x, and v is e to the x. So with that, e to the x sine of 2x minus, make sure you distribute the negative. That's a pretty common mistake, at least for regular people, not brilliant people like you. uv is 2 e to the x cosine of 2x minus v du is minus negative 4 e to the x sine of 2x. Overall, it feels like I'm going to have 3 negatives going on there. Correct me if I'm wrong. But if I distribute, I get e to the x sine of 2x minus 2e to the x cosine of 2x. And altogether, 1, 2, 3 negatives is a negative 4e to the x sine of 2x dx. So I'm feeling you'll have a 5 in your denominator?
Yeah.
Okay, so let's cut to the chase. Is your final answer e to the x sine of 2x minus 2e to the x cosine of 2x all divided by 5? Let's see. Because when you move that integral over, you'll have 1 on the left plus 4 more on the right is 5 and divided 5 by. Are we cool? Questions? All right, vector, oops, did I not? Gosh darn it.